October 24th, Tuestingtifal. Without warning, the world's defense systems come alive as satellites pivot and deep space sensors lock on target, while classified protocols tick from dormant to armed. The headlines call it routine and NASA calls it harmless. But behind the scenes, the International Asteroid Warning Network has gone to full alert, tracking something they're labelling 3i Atlas as if it might matter a lot more than anyone is saying out loud. Its light flickers in ways no comet should, and its path is a hyperbolic escape vector, like it came from nowhere and is going back to nowhere. Its chemistry, what little we can read from spectra, looks alien to anything we've catalogued. If 3i Atlas is just a comet, why is Earth acting like it's under quiet threat? Before we go further, two things. First, if you're here for the full story, watch to the end. If you prefer to jump, I've put chapter timestamps in the description so you can pick the section you want global alert, the object's anomalies, covert mobilization, official versus classified reality, the nickel code, drilling the planetary shield, the alien hypothesis, and more. Second, drop a quick comment. Where are you watching from? And what time is it there right now? I'm curious how this timeline looks from your corner of the world. Because here's the paradox, an object that can't hit us is being surveilled like it might. A campaign framed as science is structured like defense. Public statements say no threat, while actions suggest we're bracing for something we're not ready to name. Stay with me, because by the end you'll see why 3i Atlas may not be visiting us so much as observing us, and why our response might be the real story. This morning at 07, Zoro UTC, the International Asteroid Warning Network pushed a bulletin most people would scroll past without a second thought. The phrasing was tidy and careful. A routine campaign, a scientific opportunity, community participation welcome. What it did not say is what made my phone light up. Planetary-Defense protocols that are usually reserved for extinction-level risk are surfacing for an object that, officially, poses no danger at all. They have named it the 3i Atlas Comet Astrometry Campaign, and they have put firm dates on it from November 27th, 2025, through January 27th, 2026. That is 2 full months of coordinated, round-the-clock observations with telescopes on 6 continents. It is not a press release and forget operation. It is logistics, registration portals, calibration workshops, standardized error reporting, centralized data pipes. You build that when you need answers fast and you need them verified by as many independent eyes as you can get. Astrometry sounds tame. You measure where an object sits in the sky, frame after frame, and you refine its orbit. That is standard practice for near-Earth objects. What is not standard is the scale. Universities, government facilities, and a global spine of serious amateurs are all being asked to feed the same backbone. That is not academic curiosity. That is urgency. NASA's public line landed about 6 hours after the Yawn Bulletin. No threat to Earth. 4 words repeated across interviews and social feeds. Linley Johnson, Planetary-Defense Officer, went on record. Nearest approach roughly 1.8 astronomical units, about 168 million kilometers, by cosmic standards. Not even on our street. Fair. But here is what does not fit. According to multiple sources who do not speak unless there is a reason. Classified observation platforms, deep space infrared, high-gain radar, assets that usually watch geosynchronous lanes or foreign satellites, have shifted their coverage windows toward this object. One source called it a precautionary reorientation, another said protocol compliance, a third compared the mood to the scramble before 2008 TC3, when agencies had 19 hours to confirm an inbound rock to Sudan, except this time there is no countdown and, publicly, no threat. So why the energy of a late-stage response when the early-stage boxes are checked? The impact playbook is simple in spirit. First you verify the orbit with independent observations. Then you compute impact probabilities and likely corridors. Then you notify governments. Then you concentrate observational firepower to drive down uncertainty. If the probabilities stay high, only then do you discuss mitigation. You do not jump to concentrated tasking unless the math demands it. But 3i Atlas is on a hyperbolic path. Interstellar in, interstellar out. A tourist, not a tenant. There is no corridor to draw and no probability cloud punching through Earth. Yet the coordination looks like a drill that has gone live. We have seen this posture before. Apophis in 2004 earned a global campaign because, briefly, the math left a non-zero impact chance in 2029. Radar time, photometry, cross-hemisphere handoffs. Months of work until the risk evaporated. The Atlas campaign has that intensity without the impact ambiguity, which raises a simple question. What exactly are they narrowing? There is a phrase circulating among people who sit near the black boxes: anomaly detection readiness. It is not a doctrine you can look up. It is a shift in mindset. Planetary-Defense. They tell me is no longer only about rocks on collision courses. It is about identifying outliers, objects that do not behave the way the models expect, signatures that do not fit instrument baselines, perturbations that force you to ask, quickly, what am I looking at? It is less about kinetic defense and more about informational defense. If that sounds paranoid, look at the trend line. We have logged 3 interstellar visitors in less than a decade. Before 2017, that number was 0. Each one bent a different rule. One was acceleration without a coma, Borisov's comfortingly comet-like behavior, Atlas with chemistry and polarization that raise eyebrows even in cautious rooms. Each arrival widened the gap between public reassurance and private concern. So we return to the paradox that opened this story. An object too far to hit us is being watched as if it could hurt us in some other way. A campaign packaged as science is structured like defense. Public statements say no threat, while unmistakable asset tasking says pay attention. Maybe this is overreaction. Or maybe this is what a maturing planetary defense posture looks like. You do not wait for a bad day to test your arteries. You stress the system on a safe target that is just strange enough to matter. Because if you miss the anomaly when it is harmless, you will not catch it when it is not. Hold that frame. Next, we look at the object itself and why it makes smart people whisper. Let us start with what we know. 3i Atlas was picked up on the 1st of July, 2025 by the Atlas survey, the Chile site catching a faint mover that did not belong to our neighbourhood. Within days, the orbit solution made it planed, hyperbolic, interstellar in, interstellar out, only the 3rd confirmed visitor in human history. That alone earns attention, but it is not why this thing keeps pulling focus. Its kinematics are aggressive, roughly 61 kilometers per second relative to the Sun, fast enough to cover the Earth-Moon distance in about 90 minutes. Perihelion near the end of October, around 1.4 astronomical units. Safest approach to Earth near 1.8 astronomical units. No impact corridor, no probability cloud pointed at us. Safe by any public measure. And yet, there is an alignment that should make you pause. The passage comes within about 5 degrees of the ecliptic, the thin disk where most planets circulate. Interstellar arrivals are supposed to come from all over the celestial sphere. Hitting the solar system's main plane is not impossible. But it is not the default either. It is the kind of coincidence that makes modelers check their priors. Size should be easy and it is not. From brightness and assumed reflectivity, the nucleus could be under 0.5 kilometer or as large as 5 to 6 kilometers. That spread is the fingerprint of a thick coma that refuses to let us see the rock inside. With the telescopes we have, those error bars should be tightening faster. They are not, and that is a data point by itself. The activity curve is wrong for a normal comet. In August and September, beyond 3.5 astronomical units, it was already throwing off water vapour on the order of tens of kilograms per second. At that distance, the sun's heat is weak and water ice should be mostly asleep. Something else is doing the lifting. Then the spectra start to talk and what they say is stranger still. James Webb turns an infrared eye on the coma and reports a carbon dioxide to water ratio near 8 to 1. That is not unheard of, but it is rare enough to force uncomfortable origin stories. A birth in a carbon-rich, water-poor zone around some other star, or processing over eons in a radiation bath that rewrote the inventory. Either way, it does not look like the comets we grew up on. Polarimetry adds another layer. Light scattered from the coma shows extreme negative polarization, a phrase that does not appear often in cautious papers. That kind of signal hints at dust grains with odd shapes or unusual optical constants, not the silicate and organic mixtures we're used to. You can force a natural model to fit, but you have to bend it hard. And then there is the nickel. Keck's cosmic web imager pulls narrow emission lines that match neutral nickel atoms. Not ionized, not torn apart in a hot plasma, but neutral, nickel without its usual companion, iron. In cosmic material they travel together, born in the same stellar furnaces. Seeing one without the other suggests fractionation, a selective chemistry that is hard to stage on a frozen shard in vacuum. One proposed path invokes nickel tetracarbonyl, a volatile compound that forms when nickel meets carbon monoxide under the right pressures and temperatures, then photodissociates to release nickel atoms. On Earth, that is industrial chemistry. In a comet, it would be unprecedented. None of this proves anything beyond strangeness. There are natural pathways, each with caveats: exotic birth environments, unusual dust mineralogy, carbonyl chemistry in localized pressure pockets near the surface, long-term space weathering that scrambles expectations. Stack them up and you can tell a story that stays inside the lines of nature. But each plot point asks for a special condition. And the stack is getting tall. Some voices you would expect to be cautious have argued for intellectual honesty. Do not claim 3i Atlas is a spacecraft. Do not claim it is impossible either. Keep the artificial hypothesis on the table while you design observations that can disfavor it. High-resolution spectroscopy as it cools, polarimetry across phase angles, deep radio listening for coherence in the noise. If the signals fade with solar distance, you can blame heating. If they do not, you have a different problem. What matters most is the clock. Perihelion has passed. The object is outbound now, cooling and dimming, slipping under the sensitivity floor of instruments that could answer the questions we're finally brave enough to ask. If there are decisive signatures to be found, they live in a shrinking window. Miss it, and 3i Atlas will become what Oumuamua became, a lesson about how quickly the universe gives you a riddle and takes it back. You can feel it before you can prove it. Schedules shift. Windows open at odd hours. Instruments go dark on public targets and reappear a few days later with a gap that only makes sense if they were looking somewhere they are not supposed to talk about. The chatter is careful, but it is there. The deep space infrared platforms that normally keep watch on missile plumes are booking longer integrations in the anti-solar direction. High-gain dishes that live on a diet of lunar radar are filing maintenance, then emerging with fresh calibrations that match deep range work, not near-Earth traffic. The Space Domain Awareness Network that tracks dead satellites at geosynchronous is quietly ceding time to sky fields that move at interplanetary rates. No red banners, no dramatic pronouncements, just 1,000 small pivots that add up to a posture. On paper, this is a science campaign. In practice, it looks like a readiness drill where the scenario writes itself. You have an interstellar body with strange optical behavior and a chemistry profile that sits outside the median. It is not a threat in the kinetic sense. It is a question about your sensors and your coordination. Can you fuse optical, infrared, radar, polarization, and telemetry from independent stacks fast enough to call an anomaly what it is, and not what you hope it is? Can you do it across borders, across classification lines, across bureaucracies that have no muscle memory for speed unless a deadline is in flames? Inside that framing, a phrase keeps surfacing: IPD9. Nobody will put it in an email. People who use it treat it like a room you enter without phones. Interstellar Phenomena Directive 9. The informal name some attach to a bundle of procedures that only activate when the object of interest is not local. The spirit is simple, inbound or outbound on a hyperbolic path, with signatures that break your priors. You execute a layered surveillance plan that borrows from missile warning, solar monitoring, and planetary defense. Then you wrap it in communication discipline so tight that even innocent data does not leak context. You can argue the ethics of that. You cannot argue the consistency. Since Oumuamua, the machinery has been moving toward exactly this kind of response. Here is a slice of how it reads on the ground. Observatory A, tied into a national reconnaissance backbone, drops a week of scheduled exoplanet time and goes to long stare mode near the predicted track, watching for microvariability in the coma that could hint at non-thermal processes. Facility B, a coastal radar that rarely looks past the moon, requests an unusual power budget for a window on a night when atmospheric conditions are barely acceptable, then returns a null report that is not quite null if you know how to read between the lines. CubeSat constellations that sell cloud images to insurance companies suddenly need to upload firmware patches that change their pointing limits. so that stray glints near the ecliptic get culled before they hit public dashboards. Each move is defensible on its own. Together they sketch a map of intent. There is also the human side. Coordination calls balloon from a dozen invitees to 50, then collapse back to 8 with no minutes distributed. Shared Slack workspaces go quiet and move to voice. Amateur networks get asked for raw frames instead of processed products. A sure tell that upstream filters have become part of the problem. A public archive posts a maintenance banner at the exact moment a popular researcher tweets a spectrum that should not exist. None of this proves a cover-up. All of it proves that the line between open science and national security has blurred, to the point where even sincere people cannot always tell which hat they are wearing. Why pull military-grade assets into a comet campaign? Because military-grade assets are built for signal in noise. Space defense sensors spend their lives separating weak, fast, and transient signatures from a background of clutter. When you need to decide whether an emission line is chemistry or artifact, whether a flicker in the light curve is dust or modulation, whether a polarization phase swing is geometry or material, you use the eyes that were built for adversaries. You do not publish their transfer functions. You do not admit their true dynamic range. You certainly do not advertise that they were pointed at a visitor from another star. There is a second motive. If this is a drill and not a crisis, you want to test the arteries without the heart attack, tasking across agencies, deconfliction of frequency bands, data rights in mixed civilian-military pipelines, legal authority for rapid cross-border sharing, the soft parts that fail when the hard parts work. The safest time to learn where your seams are is when the object cannot hit you. You do not get many of those. When one arrives with a built-in clock and built-in weirdness, you take the shot. What would failure look like? You would see duplicated effort, gaps in coverage, and arguments about calibration constants while the object fades. You would see the same spectrum reduced 3 ways with 3 answers, and no arbiter empowered to pick the one that survives. You would see risk be translated into public relations language before it is translated into physics. What does success look like? You see quiet convergence. You see independent stacks arriving at the same conclusion with different methods. You see the artificial hypothesis neither embraced nor mocked, but constrained. You see a public statement that does not overpromise, and a private dossier that does not underplay. I keep coming back to the word firewall, not the software kind. The strategic kind. A deep space firewall is not a wall at all. It is a habit of mind, a distributed ability to recognize when the sky is delivering something outside your training set, and to keep that recognition from being drowned by noise, politics, or hope. For years, the pieces have been built in isolation. Missile warning here, solar observatories there, planetary radar in a corner, signals intelligence in another. 3i Atlas is forcing those pieces to touch, not to aim weapons, but to aim attention. There is a cost. The more you militarize attention, the more the public story lags the private one. The more you harden pipelines, the less room there is for the messy, generative energy of open science. Some of that is unavoidable, some of it is a choice. The test is whether we can build a posture that catches outliers without teaching ourselves to see enemies everywhere. We are not done with the strangeness. The next layer is the split screen between what agencies say and what their instruments are telling them. If you feel that tension already, you are not imagining it. On the surface, the message never wavers. No threat to Earth. Routine science. A rare interstellar visitor and an opportunity to learn. Every spokesperson stays inside that lane. The talking points are tight. The cadence is familiar. The reassurance is practiced. If you only follow the presses, you would think this is a beautiful curiosity passing through a quiet sky. But the data stream tells a different story, not the content at first. The rhythm. Public ephemerides that used to update hourly begin to slide to daily. Then every other day, archives that prided themselves on near real-time posting start adding soft delays. Maintenance windows with perfect timing. Spectra appear in preprints with placeholders where the most interesting band should be, pending calibration review. Polarimetry sets are teased and then retracted with new quality control language. If you watch long enough, you learn the pulse of a system. And when that pulse drags, something upstream is pressing a finger to the artery. When I ask about this lag, the answers are consistent. We are being careful. We are harmonizing calibration across instruments. We are safeguarding against misinterpretation, all defensible. None of it explains why the safest bands, the unclassified baselines, are slowing too. None of it explains why routine comet parameters now route through approval chains that look like aeronautics. Not astronomy. The split screen gets wider in interviews. A scientist who lives in spectra will nod along with no threat to Earth. But when the subject turns to composition or dust morphology, they choose their words like they are stepping through a minefield. A communications officer will insist all relevant information is being shared, and then pivot to a general statement about responsible science when you ask about the nickel lines. A radar facility will publish a schedule without an atlas window. Then a week later the schedule reappears compressed and vague, with the missing days labelled weather, even though the images from those nights are crisp and deep. I do not think there is a cartoonish conspiracy here. I think we are watching two imperatives collide. One imperative says share freely because sunlight corrects error and accelerates discovery. The other imperative says slow down because a misframed anomaly can create panic or telegraph capabilities. Put them in the same room and you get what we are living through now, a cautious public narrative that never lies outright, and a private dossier that chases every lead, including the ones nobody wants to say aloud on camera. You can see the compromise in the phrasing. Words like unusual and atypical replace the numbers that would let outsiders check the math. Confidence intervals vanish into phrases like within expected variance. Citations point to future work. Review boards expand, not to kill a result, but to keep it in a holding pattern until the security questions are answered. In the meantime, the object moves on and the best window to characterize it closes one night at a time. I am not immune to the reasons. Some instruments that can really arbitrate these questions live in grey zones. Their raw data carries signatures of how they see, and how they see is a state secret. Share too much and you reverse engineer a capability. Share too little, and you ask the public and the scientific community to accept an answer on trust. If we had built a better bridge between those worlds after Oumuamua, this would not feel like fumbling on the goal line. We did not. So here we are. There is also the media economy to consider. A steady drumbeat of no threat protects calm. It also creates a vacuum that less careful voices will gladly fill. When a careful team withholds a spectrum that does not fit, a reckless channel invents one that does. When a radar team spends a week checking side lobes and saturation limits, a rumour mill declares a hard surface glint. By the time the careful answer lands, the rumour has metabolized into narrative and no correction will fully undo it. The lesson for institutions has been do not feed the fire. The unintended consequence is that they sometimes starve the people trying to put the fire out. So what would a more honest balance look like? It would start by separating risk to Earth from significance of anomaly. You can tell the public with a straight face that the object will not hit us, while also saying that its chemistry and polarization put it at the edge of our models, and we are pushing our tools hard. You can say we are testing our planetary defense coordination on a safe target, because drills on safe targets are how you improve. You can publish the numbers that carry no operational sensitivity and be explicit about the ones you cannot share yet and why. You can invite independent observers into the process with clear guardrails so that when the answer arrives, it lands as a consensus rather than a decree. I do not expect that ideal to appear overnight. Systems have inertia and people have careers inside them. But the way this story is unfolding is forcing that reckoning. The public line can keep saying routine and harmless. The instruments are saying look closer. The gap between those two statements is where trust either grows or dies. If we want the public to take planetary defense seriously when it matters, we cannot train them to tune out the word anomaly. In a moment I will step back from the communication layer and return to the physics. Before we argue about motives, we need to understand patterns. This is not the first time we have been here. The path from Oumuamua and Borisov to Atlas explains why today looks the way it does. If you step back from the daily drip and look at the last decade as a single frame, a pattern comes into focus. Before 2017, interstellar visitors were a thought experiment. Then Oumuamua arrived and broke our sense of what a small body could be. No coma! A non-gravitational acceleration that would not die under scrutiny. Light curve hints of an elongated or flattened shape that refused to converge. Every attempt to pin it down ended with more caveats than closure. By the time the instruments we needed were trained on it, it was already too faint. The lesson was painful and simple. The sky does not wait for us. 2 years later, Borisov swept in like an answer key, a proper comet by any sensible definition, a bright comar, a classic dust and gas profile. Hyperbolic, yes, but reassuring in its familiarity. It reset the baseline. Interstellar objects could look like the comets we know. We could stop imagining that every messenger from the outside would be a riddle. Atlas does not let us rest in that comfort. It carries interstellar motion with Borisov's clarity, but overlays Oumuamua's unease. It is active too far out. Its carbon dioxide to water ratio sits sideways to our catalogues. Its polarization pushes into extreme territory. Its nickel shows up without iron. Each piece has a possible natural story, but the stack looks too much like a checklist for the word anomaly. The reaction curve is familiar too. With Oumuamua, the public message settled early on curiosity, and the private mood drifted toward agitation. With Borisov, the two were aligned because the object fit the book. With Atlas, we are back to the split. Official language keeps the peace. The posture of the instrument says, prepare to be surprised. That tension is not accidental. It is what you get when institutions learn from both previous cases, calm the public like it is Borisov, task the network like it is Oumuamua. There is also the way each visitor widened the perimeter of what Planetary-Defense means. In 2017, the phrase still conjured images of impact corridors and asteroid deflection. After Oumuamua, a quieter idea entered the room. Defense is also about classification under uncertainty, about collecting the right photons fast enough to prevent a narrative from hardening around the wrong model. After Borisov, integration improved. More hands moved in sync. Fewer silos. With Atlas, that integration is being tested at scale with an object that invites speculation whether you want it to or not. I keep returning to the timing. 3 arrivals in less than a decade after none in living memory. Some of that is better surveillance. Some of it is luck. Either way, the cadence is a forcing function. It is making us upgrade habits that would have taken a generation to change. The last time, we missed the window. This time, we built a campaign. If the pattern holds, the next one will meet a system that assumes strangeness first and designs the observation plan to burn ambiguity to the ground. What does that buy us? Not certainty. The cosmos is too good at ambiguity. What it buys is speed and discipline. It buys a public that can hear 2 truths at once, that there is no danger to Earth, and that the object is worth our full attention. It buys a scientific process that can entertain an artificial hypothesis without turning it into a circus. It buys us a shot at catching the decisive signature before it fades past the edge of what our instruments can see. Atlas is not a rerun. It is the third movement in a theme that only revealed itself after the first notes were played. The score says keep watching and keep your models humble. The pattern says the universe has more ways to surprise us than we have ways to be ready. The next section is where the pattern tightens around a single clue, a thread bright enough to pull, the nickel without the iron, and what it might mean. I keep circling back to a thin, bright thread in the data, a signature that refuses to behave. In the glow around Atlas, the spectrographs pick out nickel, neutral nickel, standing alone where iron should be standing beside it. In the cosmos, those two are siblings born in the same fires. They travel together through the histories of rocks and dust. Finding one without the other is like hearing a duet with only one voice on the stage. On its face there is a natural path. Under the right conditions, nickel can hide inside volatile cages, carbonyls that form when carbon monoxide wraps itself around a metal atom. In a warm enough pocket, those cages crack, releasing nickel into the coma while ironed. Less willing to play the same chemistry, stays locked up. It is a plausible story. It just asks for a set of circumstances that most comets do not see. You need a mix of gases tuned just so, pressures and temperatures that vary over small scales, light to drive the reactions and shadows to preserve the inventory until the exact moment the cage opens. Possible is not the same as common. The polarimetry leans into the unease. Light scattered by the dust shows a level of negative polarization that pushes past what familiar mixtures produce. That can happen if the grains are shaped in odd ways, or if their optical constants belong to materials we do not usually grind into comet dust. Again, there are models that will stretch to cover it. Each requires a choice of inputs that makes the modeler wince. There is a deeper reason this nickel matters. It is not the metal itself. It is the pattern recognition it provokes. On Earth, nickel carbonyl is an industrial reagent with a biography. It forms under controlled conditions. It moves through pipes and chambers designed to handle it. It breaks apart in predictable ways. When astronomers whisper about it in a cometary coma, they are not saying Atlas is a machine. They are saying the physics they are invoking feels engineered in spirit, if not in fact. Controlled gradients, selective pathways, repeatable yields. Nature can do all of those. Technology does them on schedule. If you want to pull this thread without letting it strangle logic, you build tests that do not care what you want to be true. You watch the nickel lines as Atlas cools. If the emission tracks sunlight cleanly, falling as the energy source fades, that argues for surface chemistry warmed by the star. If the lines persist longer than expected, you start wondering about internal reservoirs, about microenvironments that outlast the day. You compare phase angles in polarization to separate texture from composition. You push for radio observations that can sniff out simple carbon-bearing fragments that would live downstream of a carbonyl cycle. Nothing in that list is sexy. All of it is decisive. There is a timing cruelty here. The object is outbound. The coma is thinning. Instruments that could arbitrate are oversubscribed or pointed away by commitments made long before this puzzle arrived. The teams that do have time and sensitivity are balancing scientific caution with security caution, and some of the decisive measurements live right at that boundary. When you hear that a data set is under review, remember that review can mean two very different things. Sometimes it means a calibration chain that needs to be watertight. Sometimes it means people arguing about what a release would imply in rooms where implication is a currency. There is an argument that flares up every time these signatures appear. Do not entertain the artificial hypothesis. The argument goes, because even mentioning it invites noise and bad faith. I understand the fear, but humility cuts both ways. If you rule out one branch of the tree before you have the measurements that would prune it honestly, you are practicing belief, not science. The disciplined stance is simpler and harder. Keep all plausible branches alive. Design observations that can kill as many as possible. Let the survivors earn the next round. If that sounds cold, it is not. It is care. It protects the core idea that anomaly is not a synonym for miracle, and that surprise is not an excuse to stop thinking. The nickel without the iron is a surprise. It is also an invitation. Take better spectra. Take them again at different geometries. Write down the parts you cannot share yet, and be explicit about the reasons. When the window closes, publish what does not burn capability. Let the world check your arithmetic. If the natural story wins, we have learned something worth the effort. A new corner of comet chemistry, a different path through the labyrinth of dust and gas. If the natural story keeps failing, we will have to say aloud the words we have been thinking under our breath, not because we want them to be true, but because the evidence drags us there. Either way, the nickel is a teacher. It is telling us to look closer, to slow our certainty, to follow the data even when it points at a door we are afraid to open. You can feel the silence thicken before anyone admits it is there. Updates that used to arrive within the hour drift into the next day. A public archive goes into maintenance at the exact minute a spectrum starts circulating on private channels. A university observatory posts a cheerful note about routine calibration, while its staff quietly cancel talks and pull preprints. None of this proves a plot. All of it proves control. Astronomers are not being gagged in a cinematic way. They are being slowed. A draft must wait for an expanded review. A figure will need a new error analysis. A dataset cannot be released until the partners sign off because of cross-institutional agreements. Each delay sounds reasonable. Together they add up to a timing strategy that keeps the most interesting signals just out of reach of open debate, while the official narrative holds its line. The independent community feels it first. Small teams with clean optics and good discipline send raw frames upstream and stop hearing back. People who usually swap calibration files overnight are asked to use a new portal with forms that look like they were designed for export controls, not astrophotography. A few quietly build parallel archives so that nothing truly vanishes, but they know what they are risking, so they speak in hints instead of claims. Conferences become careful. The session chair reminds speakers to avoid speculative framing. Questions from the floor narrow to technique and leave interpretation alone. Slide decks lose the panels that would have sparked arguments and keep only the parts that could pass as a tutorial. The hallway conversations go longer and end with shrugs. We will see what we are allowed to see. Inside institutions, the calculus is not evil. It is defensive. If an anomaly can be misread in a way that damages trust or reveals capability, the instinct is to slow everything until the messaging is synchronized. If a result can be tied to a facility with dual-use hardware, the instinct is to treat it as if it were already classified, even if the photons themselves are not. Nobody wants to be the person who posted the plot that later becomes a problem in a committee room with no windows. There are collateral costs. Young researchers who live on rapid, open output begin to self-edit. They drift towards safe topics. The cadence that trains a field to pounce on a rare window becomes a cadence that teaches hesitation. By the time caution has done its work, the object has dimmed and the best chance to discriminate between competing models has slipped away. What remains is an after-action report that explains why the next time will be better, as if the universe will schedule the next time to fit our administrative recovery. There are ways through this that do not betray either value set. You can separate risk to the public from significance to the field and say both truths out loud. You can publish baselines and instrument response where they do not reveal anything sensitive and be explicit about the narrow slices that must wait. You can invite independent reduction of uncontroversial bands so that outsiders can test the scaffolding, even if the crown jewels are under wraps. You can admit uncertainty without treating it as a flaw. None of that fully cures the pressure to manage perception, but it creates a space where open science can breathe while security culture does what it feels compelled to do. It turns silence from a blanket into a patchwork with seams you can at least see. It gives the people doing careful work a way to stay honest without being reckless. What matters is not whether there is a hidden campaign to suppress the story. What matters is whether the habits forming right now will teach an entire community to treat surprise as a liability. If they do, the next object like this will arrive to a sky full of instruments, and a culture that looks away at the moment it should look hardest. The next step in this story is not about policy. It is about engineering a shield you hope you never have to use. If the posture we are watching is a drill with a live puzzle at its center, then the question becomes simple. Can the Planetary-Defense system learn at speed without scaring itself into silence? We have been calling this a science campaign because that is the polite word. What it feels like is a systems test with a live puzzle at the center, a rehearsal that uses a safe target to see if the shield we have been building can do more than trace predictable rocks. You do not wait for a bad day to see if your arteries are clear. You put stress on them when the stakes are low and the clock is real. In a real crisis, the question is never only what is out there. It is what you can fuse, how fast, and who can act on it without tripping over jurisdiction. Optical photometry speaks one language. Infrared radiometry speaks another. Polarimetry, radar, radio, each with its own dialect and nuisance variables. A drill forces those dialects into a common picture under time pressure. Do your pipelines tolerate odd inputs? Do your databases accept out-of-family values without quietly discarding them as errors? Does the human layer know when to override the defaults that were tuned for yesterday's sky? There is also the choreography, handing the target from hemisphere to hemisphere so the clock never drops, deconflicting frequency allocation so a radar sweep does not blind an infrared stare, asking military assets to lend you their dynamic range without making them disclose more than they can, writing down who is allowed to say what and when, so a cautious truth is not drowned by speculation. None of this shows up on a poster. All of it determines whether the picture converges while the light is still there to catch. A live test like this has homework baked in. You measure latency from photon to decision. You track how many times a result had to be rerun because two calibration chains disagreed by a hair. You count how often a human had to make a judgment call, and whether those judgments clustered around caution or initiative. You watch for duplicated effort that points to trust gaps and for empty time blocks that point to seams nobody owns. You annotate every miss and fix it before the next object arrives. The ethical edge is real. If you use a harmless visitor to refine a defense posture, say so in plain language, separate from any claim about hazard. The public can hold two truths without panic. No danger to Earth. Strong scientific interest. Active test of coordination. The point of a shield is not only to deflect a blow, it is to recognize an outlier quickly enough that you do not have to invent a response on the fly. When people hear drill, they picture checklists. What matters more is sensitivity to anomaly. You want a culture that defaults to curiosity, not fear, when the sky delivers something that bends the model. Curiosity is not softness. It is rigor under uncertainty. It tells you to design observations that can kill the easy stories fast, then spend your limited time on the survivors. It keeps the artificial hypothesis in the frame without letting it become the frame. If this is working, you will not see fireworks. You will see quiet convergence and modest language. You will see independent stacks reporting the same answer with slightly different methods. You will see a public summary that does not oversell, and a private dossier that does not underplay. You will see the window used well, with measurements taken at the moments that discriminate rather than the moments that please. If it is not working, you will feel the drag. The object will outrun the cadence. Teams will argue about constants while the signal fades. The press line will thicken into platitudes because nobody is sure which uncertainties are safe to share. The lesson will arrive too late to help. I keep coming back to why this moment matters, even if Atlas is nothing more than a strange shard of ice and rock. You do not build a deep space firewall by accident. You build it by repetition on hard but safe cases, until the habits are muscle memory. This is one of those cases. It is the rehearsal you cannot schedule and the curriculum you cannot write in advance. If we learn quickly and honestly, the next surprise will meet a system that is ready to be surprised. Every time a sky story drifts toward the word artificial, you can feel the temperature in the room change. People remember how quickly speculation can outrun evidence. They remember how long it took to unwind bad claims in the past. So let us set our footing. I am not here to anoint a conclusion. I'm here to keep a door open that evidence has not earned the right to close. The case for nature begins with humility. The universe is large enough to manufacture combinations we have not rehearsed. Carbon-rich birth environments can tilt a comet toward carbon dioxide. Radiation over millions of years can sculpt dust into odd shapes and push polarization to extremes. Local pressure pockets near sun-warmed fractures can host chemistry that frees nickel without freeing iron. None of these alone demands a machine. Together they form a story that could be true even if it is not common. The case for artifice is not a smoking gun. It is a pattern of little frictions that do not smooth out. Hyperbolic arrival along a plane that happens to intersect our busy ecliptic. Activity that wakes too far from the sun. A coma whose spectral budget leans into industrial analogies. Polarization that sits at the edge of our mixtures. Nickel lines that refuse their iron partner. Each has a natural patch. The stack of patches is what keeps serious people from laughing off the other branch. So the discipline is to ask questions that do not care which answer feels comfortable. If you suppose that something aboard is modulating outflow, you look for periodicities that hold across filters and telescopes. If you suppose the coma brightness is masking geometry, you watch for specular flashes that repeat when the phase angle repeats. If you suppose radio quiet is evidence of nothing, you tighten limits and keep listening where narrowband would have to live if it lived at all. If you suppose natural chemistry is enough, you model the thermal gradients and outgassing rates and show that the same parameters fit the light curve. The spectra and the polarization without hand-tuning each, there is a middle path that is easy to ignore. Artificial does not have to mean piloted. A device can be inert. A shard can be a byproduct. A package can be designed to leak simple molecules for reasons that have nothing to do with talking to us. If you hold that idea in mind, you stop looking only for messages and start looking for engineering fingerprints. Regularity in the irregular, stability in a parameter that should wander, a boundary condition that looks chosen rather than inherited. The risk is narrative gravity. Once the word alien is in a sentence, it pulls everything toward itself. That is why the standard of proof has to be boring. Numbers that can be checked, methods that can be repeated, predictions that survive new data, a result that points at a test and then passes the test. If the artificial branch cannot do that, it does not deserve the oxygen. If the natural branch cannot either, it does not get a free pass for being the default. What keeps me engaged with this object is not a wish. It is the way Atlas forces the process to be honest at speed. You cannot wave it away as a trivial rock. You cannot declare it a messenger and skip the hard work. You have to design observations that collapse the tree of possibilities rather than feed it. You have to accept an answer that may end up being unsatisfying. because the sky does not owe us a revelation on schedule. If the final picture says unusual chemistry and odd dust and nothing more, that is still a win. It pushes models, it refines instruments, it hardens our cadence for the next time. If the picture refuses to settle and the anomalies cross the line from rare to coordinated, then we'll have to say aloud what we have been careful not to. Not as a headline, as a conclusion that crawled there on the strength of its legs. Until then, the alien hypothesis stays on the table, neither crowned nor exiled. The right place for it is where it has always belonged, side by side with the best natural stories we can tell, waiting for the data that will let one stand and the other bow. When I strip away the headlines and the protocols, what remains is a feeling I cannot shake. We are changing the way we look at the sky, not only because an odd traveller drifted through, but because our response revealed something about us that was waiting to surface. We are building a reflex, a kind of planetary awareness that does not depend on fear to wake up. It is not the drama of sirens. It is the quiet discipline of attention. There is an idea that haunts every late-night conversation about cosmic life. The barrier between fragile beginnings and long-duration survival. Some call it the Great Filter. No one knows where it sits. Maybe behind us in the improbable chemistry that made minds. Maybe ahead of us in the risks we have not yet learned to manage. When you watch the machinery of a species learning to defend its cradle, even in practice, you can feel that barrier turn from mythology into homework. You can see the outline of a future where an unexpected visitor is not a cause for panic, but a test we trained for. That training is not only technical, it is cultural. It asks whether we can tell two truths at once without lying to ourselves. There is no danger to Earth. There is powerful reason to care. Those sentences are not in conflict. They are a sign of maturity. If we can hold them together in public, if we can separate reassurance from incuriosity, then we earn the right to ask larger questions without sounding like we are auditioning for a miracle. I think about the way surprise works on a civilization. Sometimes it breaks us into tribes shouting across a gap. Sometimes it stitches us together with a shared task. A comet with a strange chemistry should not have the power to move that needle. Yet here we are, watching the edges between science and security, between nation and planet, blur into a single field of view. We are arguing about secrecy and speed with the urgency of people who suspect that the next exam will be graded on a curve we did not set. There is humility in this too. Atlas reminds us that the universe does not owe us clarity, that our instruments are young and our models provisional. That meaning is earned by patient comparison, not conjured by mood. Paradoxically, owning that humility makes us stronger. It keeps us from declaring victory when the data are thin. It keeps us from giving up when the signal is messy. It keeps us inside the discipline of asking the question that hurts to ask, and living with the answer. If the visitor fades into history as a curiosity, it will still have left a mark, not in a crater but in a calibration, a better cadence, a tougher standard for what we call understood, a habit of testing our defences when the sky is calm so they hold when the sky is not. If the visitor refuses to fit, if the anomalies cling tighter than we expect, then the meaning widens. We will have to decide how to speak about wonder without surrendering rigour, how to protect what must be protected without shrinking the circle of those invited to look. This is the part of the story that no telescope can write for us. It is the choice to grow into a species that treats the cosmos as a place it truly lives. Not a backdrop it occasionally notices, a species that can be surprised and stay steady. A species that can build a shield without erasing its curiosity. That is the threshold that matters. Not the altitude of a rock or the angle of a trajectory, but the altitude of our habits and the angle of our gaze. There is a new kind of eye opening above the world, an instrument designed for a different century that happens to be arriving in this one. The nickname on private channels is Chanlong, a dragon that sees in ways our older telescopes cannot. The language around it is cautious, a technology demonstrator, a pathfinder. The ambition is not, imagine an array that marries exquisite timing with entanglement-assisted metrology, a system tuned to squeeze more information from fewer photons, to recover structure where classical optics give you blur. On paper, it is a research project. In practice, it sits at the hinge between curiosity and security. The promise is resolution without brute force. Traditional astronomy buys clarity with mirror diameter and time. Quantum techniques promise a different currency. Correlated detections that lift signal from noise. Non-classical light that sharpens a fringe. Phase information preserved through turbulence that would ordinarily smear it away. None of this is magic. It is engineering stacked on theory. Picky about stability and calibration. Demanding about temperature and timing. Get it right and you can reach into the dim outskirts of a coma and pull out texture. A regular scope would never separate from the glow. When I listen to the people working near this line of research, they choose their words carefully. They talk about correlation functions and timing jitter, about baselines that behave more like a radio interferometer than an optical dish. They talk about the pain of keeping the system honest, of proving to themselves that a sharp edge in a reconstruction is not a fingerprint of the algorithm. They also let slip small, telling things. A test run that showed a feature in a calibration target that matched a known defect. A night when the sky would not cooperate and the instrument still pulled a curve that agreed with an independent stack. Little victories that look like the beginning of trust. Fold that capability into a comet campaign and you get a new way to ask old questions. Is the light curve hiding geometry? A quantum-enhanced image can hunt for the weaker symmetries that betray shape under the coma. Are there microjets in the outflow that turn on and off faster than your exposure can usually catch? Correlated photons and ruthless timing can map flicker that a normal camera averages into a smear. Is there a boundary between dust regimes that hints at layered material? The right reconstruction can sharpen contrasts that would otherwise melt away. There is a reason this sits near the security line. If you can resolve a dim, moving target far out, you can do more than astronomy. You can count panels on a dark satellite at a distance that used to be unreachable. You can read the behavior of a plume from a distant engine test without flying a sensor through it. Those abilities are not the goal of a comet campaign, but they are passengers on the same train. That is why the language around deployment stays gentle while the schedules stay firm. That is why a laboratory demonstrator becomes operational just in time to watch an interstellar visitor without anyone making a fuss. I do not need a schematic to guess the internal debates. How much do you publish about the instrument response? How far do you let outsiders probe the pipeline? What targets do you admit to observing? And which do you label routine calibration? The best scientists in these projects want their work judged and improved in the open. The best defenders want their edges kept quiet. Somewhere between those two impulses, pictures are being made that could settle arguments about Atlas if we were allowed to see them with full context. Any new eye has to prove it is not dreaming. The discipline is the same whether the technology is classical or quantum. Cross-check against independent methods. Blind yourself to the answer and see if you still recover it. Show that your sharpness degrades when you deliberately break the correlations that give you power. Only then should you trust the features you attempted to interpret. The people I trust say that process is underway. They say the first passes on Atlas align with expectations in ways that build confidence, without claiming breakthroughs they cannot defend. What would a breakthrough look like? Not a photograph of a machine gleaming inside the coma. It would look like modest clarity at just the places where inference hangs. A repeatable brightness asymmetry that points to a stable geometry. A narrow filament that behaves like a controlled outflow rather than a random vent. A boundary in grain size that stays put when the illumination changes. Small, stubborn regularities that refuse to behave like noise, even if the instrument delivers only incremental gains. The implications are large. A world that can bring quantum techniques to bear on dim, fast, far targets is a world with a new tier of perception. It means future visitors will meet an eye that wastes less of their light. It means the time between anomaly and characterization shrinks, and with it the room for bad narratives to take root. It also means the conversation about what can be shared will get harder, because the line between scientific image and capability demonstration will blur further than it already has. For now I am left with a simple, grounding thought. The sky is the same as it was before this instrument woke up. We are the ones changing. We are teaching our tools to see more with less, and to do it under conditions that used to be an excuse, if Atlas did nothing else. It arrived at the moment when that lesson was ready to graduate from lab bench to night sky. That timing might be coincidence. It might be luck. It might be the first hint that our next arguments about this object will not be about what we missed, but about what we can finally see. There is a kind of seeing that does not wait for the photon. Give a model enough nights of sky, enough labelled bursts and quiet stretches, enough correlations between solar wind, geometry, grain chemistry, and instrument quirks, and it will lean forward. It will tell you where the next brightening lives before the coma decides to bloom. That is not prophecy. It is pattern recognition at a scale no single team can hold in their head. The story that keeps coming up is simple and unsettling. A JPL-built pipeline flagged a pending surge in Atlas's activity, roughly 72 hours before the first human teams called it. The alert did not come as a trumpet blast. It slid across an internal channel as a probability trace climbing past a threshold that had been tuned on years of comets that never made headlines. When the surge arrived on schedule, the model earned trust it will not easily lose. Once a tool can do that, everything around it shifts. Scheduling is no longer reactive. You pre-commit radar windows before the vent wakes. You stage infrared time on the nights the chemistry will talk loudest. You position polarimeters to catch the exact phase angle where grains betray their shapes. You move from watching to feinting, drawing out the object's behavior with a choreography. The object does not know it is dancing to, but the gift comes with a knot. Who sees those forecasts? The raw inputs live in a messy mix of public and restricted streams, ground telescopes, space-based sensors, niche instruments that do not like their names in print. Share the model's outputs too widely, and you invite questions you cannot answer without drawing a map of capabilities. Share them too narrowly and you starve the independent checks that keep a field honest. Somewhere in that tension sits a policy that does not yet exist. There is also the problem of explanation. A model that hits the right nights for the wrong reasons is a liability, not an asset. If the forecast hinges on a spurious correlation, a seasonal bias in an archive, a compression artifact that the training set accidentally learned as a proxy for physics, then the first truly novel object will make a fool of you. The teams I trust are not blind to this. They demand ablations and counterfactuals, tests where you strip out parts of the input and see whether the confidence holds. They track false positives and false negatives like aircraft logbooks, because a system that never cries wolf is usually a system that misses wolves. There is a human edge that no code can replace. A model can state that the probability of a surge is rising. It cannot tell you which instrument is most likely to arbitrate the reason. That is still craft. A spectroscopist who knows where carbon dioxide likes to hide. A polarimetrist who knows when a phase curve will lie. A radar engineer who can read a faint return and say with a straight face whether a glint is geometry or gain. The best use of AI is not to replace those instincts, but to aim them when time is tight and windows are few. The governance question does not go away. If a forecast engine can move resources, it can move narratives. A confident prediction of a brightening that does not arrive will be read as hype by people looking for a reason to stop listening. A quiet model that withholds a strong signal until the last minute will be read as gatekeeping by people tired of being asked to wait. The only antidote is ritualized transparency that does not leak what must not leak. Pre-registered forecasts hashed and time-stamped. Post-event releases that compare prediction to outcome in public. Clear statements about which inputs were used without listing the ones that cannot be named. It is not perfect. It is better than trust us. Put this engine next to Atlas and you get a chance to test more than code. You test whether a community can let a machine lead without surrendering judgment. You test whether institutions can share just enough to let outsiders verify the win rate. You test whether the next time a model whispers anomaly, the people who need to hear it will listen even if the press line still says routined. If this works, the cadence of discovery changes. We stop losing the most interesting minutes to surprise. We stop pretending that human reflexes alone can keep up with skies this busy and this strange. We build a loop in which models propose, instruments expose, analysts dispose, and the whole cycle tightens until the gap between what the sky does and what we know about it feels less like an abyss and more like a beat we can dance to. If it fails, the damage will not be technical, it will be cultural. A generation will learn that forecasts are theatre, that the real work happens in rooms they cannot see, that openness is a slogan rather than a practice. That is not a future I want. The machine that called Atlas's brightening early did not just buy us a better light curve, it handed us a chance to learn how to be both faster and more honest. Whether we take that chance is not a question for code, it is a question for us. something strange unfolded just as Atlas began its slow approach toward the inner system. In early August, deep in the Antarctic ice, the neutrino detectors registered a burst of high-energy particles unlike anything in the recent record. A spike, short and clean, lasting only minutes. At first it looked like a calibration artifact, some quirk in the data stream, but the timestamp held. The direction vector pointed almost exactly toward the inbound track of 3i Atlas. It was not the only tremor. Space weather monitors around the sun began logging a subtle but measurable rise in background radiation at energies too high to link with any flare. Magnetometers saw a faint flutter that didn't fit known solar cycles. Each anomaly, taken alone, was a curiosity. Taken together and laid across the timeline of the comet's arrival, they began to look like the edges of the same event. Official channels said little. The neutrino burst was filed under inconclusive, the radiation uptick under instrument drift. But off the record, researchers began comparing notes, whispering about a coincidence too sharp to ignore. The energy release was small on cosmic scales, yet precisely timed with Atlas's first visible outgassing. Some wondered if it was a random overlap, a cosmic echo from some distant astrophysical source that happened to ring through our detectors at the perfect wrong moment. Others, quieter still, asked if it was the other way around, if the comet wasn't reacting to a background event but was, somehow, part of it. No one is suggesting that Atlas fired a beam or triggered a pulse. The scale of the numbers rules that out, but there's a subtler interpretation that the object passed through a region of space charged by an earlier event, and in doing so, interacted in a way we don't yet model well. A grain of cosmic dust, a remnant magnetic structure, a shell of particles left behind by something older. The timing, the direction, the faint spike all could be traces of that intersection. For the agencies tasked with defense, it didn't matter whether the link was causal. It mattered that every instrument designed to warn of deep space hazards reacted to the same line in the sky at the same time. That coincidence alone was enough to raise readiness levels, to call up reserve analysts, to cross-check detection algorithms that had been sleeping for years. In the language of systems, this was a stress test you could not plan, an unscheduled load on every network we use to watch the universe. It exposed gaps, showed which sensors talk too slowly, which archives choke when data floods in from multiple sources. In that sense, the spike may have done us a favour. It reminded us that the cosmos still writes our drills. I keep thinking about scale. On our side of the telescope, a flicker in the neutrino flux feels enormous. On the scale of the galaxy, it is barely a sigh, but it came at the exact moment an interstellar traveller brushed our light. Maybe that's all it means. The universe clearing its throat while we happen to be listening. Or maybe it means that even the smallest visitors can ring the instruments of an entire world if we've tuned ourselves to notice. Either way, the spike changed the story. It turned Atlas from a curiosity into a case study, and it left a quiet question hanging in the background noise. What else is out there, faint and fast, playing the chords we haven't learned to hear yet? For years, the phrase space militarization sounded like a headline from a distant future. Then, quietly, it arrived, not with launches that carried obvious weapons, but with sensors, catalogues, and procedures that knit a vigilant skin around the planet. You can feel it most clearly when an object like Atlas appears. Civilian astronomy brings curiosity and craft. The defense world brings persistence and reach. Put them together and you get something new. A perimeter that is less a wall than a reflex. The deep space firewall is not a single facility. It is a habit made technical. Constellations that watch for missile plumes can also watch for odd comae. Ground radars that map debris at geosynchronous can stretch their gaze and test a faint return at interplanetary ranges. Optical networks that track satellite conjunctions can pivot to follow a hyperbolic intruder through the gaps between scheduled passes. The pieces were built for different reasons, but they interlock when the sky delivers an outlier. This integration does not announce itself. It shows up as coverage that never quite sleeps. A handoff from one hemisphere to another that arrives without drama. A downlink stream that remembers to keep the raw levels so an unexpected line in a spectrum can be re-reduced 5 different ways. A playbook that knows who must be on a call and who should only see the summary. In a crisis, that machinery would be loud. In a drill with a live puzzle at the center, It hums under the noise floor of daily life. None of this is neutral. The more we rely on defense-grade eyes to fill the gaps in our picture of the sky, the more we accept the gravity that comes with them. Data rights bend toward caution. Timelines stretch to fit review cycles written for other kinds of risk. International cooperation follows channels built for alliances and treaties rather than labs and journals. You do not have to be a cynic to see the trade. Speed and depth in exchange for a tighter grip on the narrative. There is a counterweight if we choose to build it. We can formalize lanes where openly funded instruments promise to publish baselines on a clock no committee can override. We can define thresholds where dual-use data must be redacted with a scalpel and not a tarp. We can teach the public to hear the difference between no danger and nothing to see. We can keep a place at the table for the independent networks whose agility often spots the thing everyone else walks past. Atlas revealed another layer of this quiet revolution. Space is no longer a blank arena where only rocks and machines drift. It is an information battle space. Even in peacetime, the goal is not to fire, it is to know if an outflow is thermal or controlled, to know if a glint is geometry or modulation, to know if a signature that looks like chemistry is in fact chemistry, and not an artifact of how you chose to look. That kind of knowledge demands fusion across disciplines and jurisdictions that rarely share coffee, let alone code. There are legal and ethical questions we have not finished asking. What counts as surveillance when the target is a natural object? What obligations do nations have to share characterization that bears on global safety, even when the data touches classified capability? How do you audit a result that depends on sensors you're not allowed to describe? These are not academic puzzles. They shape whether the next public statement lands as trusted science or as something closer to decree. For all the discomfort, it is hard to ignore the gains. The deep space firewall shortens the distance between anomaly and understanding. It catches slips before they metastasize into stories that take months to unwind. It builds a culture where a phrase like informational defense carries weight alongside kinetic defense, where recognizing the odd thing quickly is itself an act of protection. There is a line we have to keep drawing. Militarizing attention is not the same as militarizing intent. We can choose to keep the shield pointed at the unknown without teaching ourselves to see enemies in every shadow. That choice will not be made in a single policy or a single press conference. It will be made in the thousands of small decisions that determine who gets the data first, who is allowed to speak, and how soon the rest of us can check the math. Atlas has been a teacher in that regard. It arrived at a moment when the apparatus was ready to show us what it had become. It showed us the strengths of a system that can move quietly and quickly. It showed us the frictions when openness meets secrecy on a clock the sky does not slow to accommodate. Most of all, it showed us that the firewall is real, and that it is as much a cultural artifact as a technical one. The final chapter of this story will not be written by a censor. It will be written by how we choose to stand at the threshold that waits for every species that learns to look outward without blinking. I keep returning to the first sentence I spoke when this began. Without warning, the world's defense systems came alive. Weeks later, the warning feels less like an alarm and more like an awakening. The object is receding. The light is thinning. The arguments are still warm, but something quieter has settled in. We just practice being the kind of species that does not wait for impact to take itself seriously. That is the threshold. Not a line in space, a line in habit. We built a campaign on a visitor that could not hurt us because it might teach us. We fused instruments that were never meant to speak to each other because the puzzle insisted. We let models lead and then demanded that humans verify. We held two truths in the same mouth without choking on either. No danger to Earth. Full attention required. For the first time, that sentence sounded normal. I do not know what 3i Atlas is in the last analysis. I know the shapes of the stories it offered. A shard from a carbon-rich nursery, processed by ages of radiation into dust that plays strange tricks with light, a body with vents that wake too far from the sun, and a chemistry that leans on carbon dioxide the way our local comets almost never do, a spectrum where nickel sings without its iron partner and dares us to explain why, a traveller whose path leans into our ecliptic like a coincidence that refuses to sit quietly. Each thread can be tied to nature with enough patience and care. None of them sits comfortably when you knot them together. That discomfort is not a failure. It is a gift. What matters now is what we do with the gift while the window is still cracked open. Publish what can be published with numbers that let strangers check the arithmetic. Admit what cannot be shared yet and say why without hiding behind theatre. Freeze the cadence we just learned into muscle memory. So the next time our instruments feel the sky tilt, we do not spend the first nights reinventing the calendar. Build the lanes where open science and guarded capability can run in parallel without tripping each other. Teach the public to hear the difference between reassurance and dismissal, so that calm is no longer mistaken for indifference. There is a temptation to end on a proclamation, to crown the object as one thing or the other. The honest ending is smaller and harder. We crossed a maturity line. We discovered that the deep space firewall is not a fantasy. It is a network of people and tools that can hold a question in a steady grip without crushing it. We learned that secrecy can protect a capability and still starve a field, and that the cure is not to rip away the veil but to cut it with care. We learned that models can see around the corner if we refuse to worship them, and if we insist that every forecast carry the burden of explanation. We learned that new eyes can open, quantum or otherwise, and that their first duty is to prove they are awake before they claim to see. When I think about what will remain after the plots and presses fade, I picture a map of nights, dots where an observatory chose the sky over comfort, dots where a team said no to a headline and yes to another hour of calibration, dots where a young researcher hit send on a careful result and decided that patience was a kind of courage. Those dots connect into a line that crosses the threshold I'm trying to name. It is the line that separates a world that is flattered by mystery from a world that is responsible to it. Maybe the next visitor will be boring in all the right ways and we will call that mercy. Maybe the next will be stranger and the arguments will sharpen. Either way, the posture we just rehearsed is the one we will need. Not the posture of certainty, the posture of readiness. Ready to test our own stories first. Ready to use every sense without confusing sensitivity for fear. Ready to let the conclusion arrive at its own pace instead of dragging it to ours. I asked at the start where you were watching from and what time it was there. I think I understand now why the question mattered. This was always about more than an orbit. It was about synchronizing a planet to a problem in real time. About discovering whether a phrase like Planetary-Defense could mean attention as much as armor. It turns out it can. It turns out we can be many places on the clock and still move like one mind when the sky offers us a riddle. The light from Atlas will keep fading. The papers will keep arriving. The debates will keep doing what debates do. Somewhere beyond the edge of our reach, another object is already on its way, indifferent to our schedules and our pride. When it comes, I want us to remember how this felt, the quiet braid of caution and curiosity, the willingness to stand on a knife between open and guarded and not fall, the sense that we were not just looking out but looking back at ourselves and deciding, finally, to grow up. That is the threshold, not a moment on a calendar, a posture we can choose again. If we keep choosing it, then whatever 3i Atlas turns out to be, it will have earned its place in our story, not as a threat, as a teacher. I will leave you with this. The sky will keep writing its quiet messages whether we are listening or not. 3i Atlas is already fading, but the posture we found does not have to. If you want to revisit any chapter of this investigation, the timestamps are in the description. If you stayed with me to the end, tell me where you're watching from and what time it is there. I want to see the map of voices that shared this night. I'm going to keep watching the outbound track, comparing every new spectrum and light curve to the best stories we have told so far. When something shifts, you will hear it here in plain language, with numbers you can check and questions we can argue honestly. Until the next visitor, keep your curiosity sharp and your certainty soft. The universe rewards that combination.